Hello guys. So let's start day 4 where we will be discussing about next all the related matrix operations, right? So please go through my last video, which is video number 3, where we started some of the basic matrix multiplications, matrix subtraction, matrix addition. All are those are very basic, matrix operations. Now this part we'll be trying to cover up some of the special matrix. Now in out of those special matrix, one of the special matrix operation is diagonal matrix. And diagonal matrix means what? We have seen identity matrix. In identity matrix, all elements should be 0. Only your main diagonal element will be 1 1 1 1, right? 1, only 1, right? Similar kind of concept. Here there is a little bit of changes. What I am trying to say here, I am saying my main diagonal have different values, okay, and other elements should be 0. What does that mean? Let's say my D is equals to the matrix I'm talking about. In this D matrix, I will have all the values 0 other than the diagonal matrix. See, there are two diagonals in a matrix always. See, this is one diagonal and this is second diagonal, right? Out of these two diagonals, you can see the first one is my main diagonal. Please just understand the concept, okay? Understand the concept. So always when I'm talking about the identity matrix, I'm talking about a diagonal matrix, I'm talking about the main diagonal. In this main diagonal, the elements should be different, not same, and also the other elements in that particular matrix should be 0. That is called diagonal matrix. Similarly, we have a matrix called operation type called orthogonal matrix. What is this called? Orthogonal matrix. What is orthogonal matrix? Orthogonal means, I think you guys know, right? Perpendicular kind of stuff, right? So if your matrices can be called orthogonal, oh sorry, my speaker got power up, right? So if I'm saying orthogonal, what does that mean? I'm trying to say A into A transpose into A is nothing but I, or I can say something like this: A transpose is equals to I by A is nothing but A inverse. Okay, don't be scared, get scared. This is a simple formula. So this is my rule to be a orthogonal matrix. So if I am saying let A be a matrix, okay, is equals to a matrix, right? The matrix I am talking about mostly square matrix, okay. So what is square matrix means? You need to know that, right, as well. So square matrix means, if we will be considering square matrix is nothing but your M cross N should be nothing but M is equals to N. What does that mean? If your M is 4, then N should be 4. If your N is 2, N should be 2. If your N is 3, it should be 3. So if they are equal, then that can be called as a square matrix. So if I'm saying A is a square matrix, where the formula A transpose at A, we know what is transpose means. Transpose means changing the columns to rows to column, right? So A transpose into A is nothing but an identity matrix. This means identity matrix, right? Identity matrix. So if this is my identity matrix, so what I can say, I can take an example and trying to figure it out whether it is satisfying the rules or not. If I'm having a matrix, let's say A equals to 0 1 0 1 1 0. So now this is not an identity matrix, right? Why? Because this is not the diagonal elements are 1 in one diagonal, but that is not my main diagonal, right? So what should be the A transpose? A transpose will become this row becomes column becomes row, right? So this becomes 0 1, same, right? There is no changing happening, right? 1 0, right? That is what A transpose is. The moment you will be writing A into A transpose or A transpose into A is nothing but 0 1 1 0 multiply with 0 1 1 0, right? So if you be looking closely, this is nothing but matrix multiplication, right? Matrix multiplication, I have already discussed about it. If you will be doing it 0 cross 0 plus 0 cross 1, and 1 cross 1 plus 1 cross 0, right? And then 1 cross 0 into plus 0 cross 1, and again you are doing something like did I made some mistakes? I made some mistake, right? Let me do it again. Let me do it again. Sorry. If we'll be writing this with this, okay, and this with this as well, right? So that is what we are going to do, right? So if you'll be finding out, it is nothing but 0 cross 0 plus 1 cross 1. Yes, like that if you'll be figuring it out, it will become 0 cross 1 plus 1 cross 0, and then this will become 1 cross 0 plus 0 cross 1, and this becomes 1 cross 1 plus 0 cross 1. It's nothing but you will be figuring it out 1 0 0 1, and whatever you are seeing right now, this is nothing but an identity matrix, correct? It's a 2 cross 2 identity matrix. The identity matrix can be any cross, right? That should be a square matrix. Now if we'll be looking closely, what I told you, this is a m cross n matrix, this is a n cross p matrix, and this is matching. So I am having m cross n, m cross p. Now this is my m, this is my p, right? This is my m and this is my p, both are same. So if you will be multiplying two square matrix, you will be getting another square matrix only. Clear? So this is how orthogonal work. If your matrix can be multiplied with, if your matrix is multiplied with the transpose of that same matrix, and it is giving you identity matrix, then we can call A is a square matrix. Oh sorry, A is a square orthogonal matrix. Orthogonal matrix. Now I don't want to write square, it's just like square, that's why I am writing it, right? Orthogonal matrix. But main thing is it is a orthogonal matrix. Okay, if orthogonal matrix is done, we'll be jumping into something called symmetric matrix. Okay, we'll be jumping into something called symmetric matrix. Okay, what is symmetric matrix? Symmetric matrix, it looks like understandable, right? Symmetric matrix means what? If you have a mirror, symmetric means what? If you have a mirror, whatever you are seeing here is kind of seeing here as well, right? That is what symmetric means, right? So in symmetric matrix, what we are trying to say, if you have a square matrix, okay, if you have a square matrix where you will have A is nothing but the transpose of it. A should be equals to the transpose of it. What does that mean? If I'm having a vector, let's say 1 2 3 4 or 2 3 1 2 2 3, and I'm having a transpose of it, 1 2 2 3, you can see the matrix are actually similar, right? They are both similar, right? After transpose also it just looks similar, so it is nothing but A is symmetric matrix. A is symmetric matrix. You can change anything, you will be getting similar kind of result, the values. But the similar kind of result, the values will be kind of similar, will be looking like. But if you remember some kind of these formulas, the formulas are not needed, but if you will be understanding concept like naming conventions, like symmetric, the way I told you, right, the mirror concept, it will be easy to understand, because you cannot remember a lot of formulas in your life, right? So it's better to understand and learn it better like machine does. Clear? Okay, so I'll be jumping into next one, which is nothing but inverse of a matrix. Now this is the crazy part. The inverse of a matrix is a crazy part. The thing is, to find out inverse of a matrix for a 2 cross 2, it's pretty easy. There is a formula to it. I'm going to tell you. So inverse of a formula means, I'm trying to say, if I'm having A is equals to a square matrix, okay, inverse of a matrix is nothing but in A to the power minus 1. This is inverse of a matrix. Now if this is the case, there are some rules to it. The rules are pretty simple. If you have A and A to the power minus 1 is A inverse is nothing but your inverse of a matrix of the same matrix. This will be giving you something called identity matrix. Formulas. Same, if you will be doing A inverse into A, it will be giving you identity matrix. What it will be giving you? Identity matrix. Now tell me one thing. Okay, if you will be saying, okay, why these things, it is already proven one, it is already somebody calculated, you also can be calculating these things, you will be getting how I is coming, like the orthogonal part of it, like we did some orthogonal thing, right? It was working really well. So now think about, I told you like if you have a square matrix which is a 2 cross 2 matrix, it is pretty easy to calculate, right? Pretty easy to calculate. Now think about the formula. The formula is, if you have a matrix which is nothing but 1 3 2 4, now if we will be changing the, now if we will be interchange, okay, we will be interchanging 1 and 4 and change sign of 2 and 3, sorry, 2 and 3. So what is this mean? See, I'm saying you should be changing the position, interchange of position 1 and 4. So that main diagonal position should be interchange, so 4 and 1. The other diagonal position should be having negative, change the sign of it, so this is negative sign. So it will be, the value should be as it is just you are changing the sign of it. So now this is nothing but my A inverse. See how easy it is? This is easy, right? Now if I will be saying, you have to now divide by its determinant. So this is not the final inverse I am talking about, this particular one. So if you have to do one thing, what you have to do, you will be saying A inverse is equals to 4 1 minus 2 minus 3 divided by A determinant. Now we will be discussing about A determinant. What is A determinant? A determinant is nothing but, if A is a matrix of 1, we had 1 2 3 4, right? So 1 3 2 4, 1 3 2 4, your A determinant is nothing but, it's like multiply this respective value, which is 1 into 4 minus 3 into 2 or 2 into 3, whatever. So it is nothing but 4 minus 6 is equals to minus 2. So if you go here, this is nothing but 1 by minus 1 by 2 into 4 minus 3 minus 2 1. Think about it. What is this? Very simple. Scalar. What is this? Matrix. So what does this mean? We are doing scalar multiplication of a matrix, and if you will be doing it, you will be getting the response, you will be getting the result is nothing but, if you will be having minus 1 by 2 into 4 minus 1 by 2 into minus 3 minus 1 by 2 into minus 2 and 1 by minus 1 by 2 into 1. If you will be doing properly, this becomes plus, 2 cancel, and this is this, it will be around what will it be? It will be around minus 2 and 2 minus 2 and minus 3, so 3 by 2 minus 1 by 2, this is 1. Guys, this is pretty simple to do it, the determinant thing and inverse thing. Now whatever you are finding, this is the final inverse. Okay, this is my final inverse value, So if we'll be seeing, your final inverse A inverse is nothing but 2 3 by 2 1 minus 1 by 2. Any doubt about it? Any doubt? The moment you will have any doubt, just comment down below. I'll be replying every comment of yours. Okay, don't worry. You feel like, okay, I will be busy, whether sir will be replying or not, I am going to reply. So the inverse which I wrote it here, isn't it the exact inverse? So what I will be going to write, it is called adjacent of A. So to get adjacent of A and A inverse, the A inverse formula becomes A inverse is equals to 1 by determinant of A into adjacent of A. Adjacent of, this is your A inverse formula. Now because that other one is actually the adjacent to A, is actually pretty easy to do it, that's why I did it. Okay, now if I will be taking a 3 cross 3 matrix, okay, naked, let's take a 3 cross 3 matrix and we'll try to figure it out how we are going to do it using inverse methods. Okay, so if you have time you can go for it, but if I will be giving too much time on 3 cross 3 matrix, it will be taking too much time. So I will be discussing about it in another video. For by the time you can go and practice about this 3 cross 3 matrix. Okay, if you're not able to do it, I'll be covering up, don't worry. So should I cover it? Should I cover it? Okay, let's cover it. Okay, that is a better way to do it. So if what I am trying to say here, if I'm having a matrix, let's say A is equals to, let's take an example. Let's if it will be bigger time, sorry, it will be bigger videos, then it's okay. Hopefully you guys are okay with it. If this 2 minus 1 3 4 1 and 8, the moment I am saying this, first I need to find out the determinant, which is this, which is nothing but, you can write it as like this. It's nothing but, you will be saying this and this, ignore this first row, first column, ignore whatever you are finding, multiply them, minus them. So it is 8 into minus 1 minus 1 into 3. Getting what I am trying to say here? Any point you are facing, any issue will be saying. So I am considering 1 here. So I am taking 1 into. So see what is happening. So it is nothing but 1 into 8 into minus 1. So that is means minus 8 and minus 1 into 3, right? So then again we will be going for this position. Okay, we will be going for this position. Second, see carefully, second column, first row. Okay, the value is 0. Okay, so if I am writing something like this, it becomes, look at this, minus. Okay, because the position value is, this is 1 0, right? This is 1 0. It's better to go with 1 1. So that is the better way to do it. So if I'm saying first row, first column, first row, second column, first row, third column, that becomes, it's an odd number, which is even, odd, this column is again even. So 1 is a even number, 0 is a odd number, so that's why I'm taking minus. Okay, and minus, then I'm having a value of 0, and of course I know whatever you will be multiplying with it, it will be 0, but the meantime I'm just saying you multiply 2. Look at this green color one, you are ignoring this and this. At that point of time you will have to multiply 2 with 8 and 4 with 3. Hopefully you guys are understanding the diagram. 2 with 8 minus 4 into 3, and then okay, this is, I will be writing 8 into minus 1 into 3, that is the way. Then again I'm going to go for the third one. The third one is what? The third one is this particular column and this particular, again the same row. So the value is actually this one, 2, and because it is your even number, the even number position, I am writing plus 2, multiply. See this, the multiplication should be around what? You are ignoring this, so this will be 2 1 4 minus 1. See carefully. I am not going to make any mistakes, but you just check it out. If I will be making any mistake, you will be correcting me out. 4 into minus 1. So if you will be finding out determinant, you will be finding, okay, 1, 8, minus 8, minus 3, minus 0 I am writing because this is becomes 0, right? The whole term becomes 0. So 0 plus 2 into 2 minus, so minus plus 4, right? So your determinant of a value, it's nothing but minus 8 minus 3 minus 11 plus 4 6 12. So is equals to 1. Always remember, the moment here becomes equal, this is a note, this is a note, this is a note. Your determinant should not be 0. Your determinant value, if your determinant value of a matrix is equals to 0, that means determinant of a is equals to 0. That means what implies a inverse not possible. Why? Because our a inverse is nothing but determinant of a divided by a, sorry, determinant of that's not determinant of a. See the formula again. It's where I wrote here, so the formula is adjacent of a divided by what? Determinant of a. So your denominator cannot be 0, right? That's why I am saying a inverse time, when you are finding a determinant of a matrix, it should not be 0. If it is 0, you should not go further, and you will be saying the inverse of a matrix is not possible. Okay, so your determinant is becoming 1, right? The determinant value is actually 1. If your determinant value is 1, you will be going for the coefficient matrix. What matrix I am saying? Coefficient matrix. The coefficient matrix is adjacent matrix. Okay, so let's find out coefficient matrix. Coefficient matrix. Now when I am talking about coefficient matrix, because the plus minus sign is now very much important. Okay, whatever we discussed here now will be covering. Now currently we did determinant for only one particular row, and we multiplied with 0 1 2. So now we will be doing the same thing for 9 times, because we are going to find out the similar value for 9 positions. So this is why for each position you will be calculating. What we are trying to do here, we are trying to say for each position we are finding a 2 cross 2 determinant. And we will be applying plus and minus symbol. Obviously the even odd concept, you will be applying plus or minus signs. These are all even odd symbols, right? So now if we will be going for a C11, the 1 1 position. Okay, before that I will be writing that matrix again. So our A matrix is nothing but 1 0 2 2 1 minus 3, 1 0 2 2 1 minus 3 4 1 8, 1 0 2 2 minus 1 3 4 1 8. Again I am saying these are random numbers I have taken. So now this is my C11 position. So C11 position, that is my coefficient 1 1 position. Then 1 1 means 2, right? The position is even position. Remember that the position is even. What I am trying to say, if it is a even position I am writing plus, then in between I am having a matrix. The matrix is actually, you will be ignoring this, that means the matrix which is coming again minus 1 3 1 8 is nothing but minus 8 minus 3. Then find the determinant of it. Once you will be finding the matrix of 2 cross 2, this is a 2 cross 2 matrix, right? You will be finding the determinant of it. So determinant is 8 into 1 3 into minus 1, and outer will be plus, right? So this is nothing but minus plus minus 11. Clear? Hopefully you guys are clear. This is the best way I can explain you guys. Okay, and then again I'm trying C12. Okay, the C12 will be 2 plus 1 3, that means minus, so you will go C1 and 2, C1 and 2. So your vector will be 2 3 4 8, 2 oh sorry matrix, sorry, the square matrix, 2 cross 2 matrix, 2 3 4 8. The 2 3 4 8 will becomes minus of, find the determinant, 16 minus 12. 16 minus 12 is 4, so it will be minus 4. Similarly C13 is nothing but this and this, so this becomes 2 minus 1 4 1. So this is 3 plus 1 is 4, so this becomes plus 2 minus 1 4 1, and that becomes plus, it becomes 2 minus minus plus 4 is nothing but 6. Like this way you will be calculating for every row's element. So you will be having C21, so T1 means this particular row, this particular column. So if this particular column is ignoring, then you becomes 1, this 0 2 1 8. See carefully, so this becomes 2 plus 1 is 3 minus, then see this second row first column you will be ignoring. What are the remaining numbers? 0 2 1 8. Okay, 0 2 1 8. Find the determinant of it. So 8 into 0 0 minus 2 into 1 2 is nothing but plus 2. Okay, similarly you will be calculating for C22, you will be getting a value. Okay, you will be getting a value of 0. So you will be getting C23, you will be getting a value of minus 1. Okay, I am going for C31. Again I want to explain it again. C31 is third row first column. Okay, so third row first column will be 3 plus 1 4, that is plus. Third row plus 1 ko ignore it, this one and this one ignore it. So remaining element will be 0 2 minus 1 3, 0 2 minus 1 3, minus 1 3. Now you will be finding the determinant of it. 3 into 0 0 minus minus plus 2 plus 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 2, so you will be getting 2. So similarly you can find out C32, it will becomes 1, C33 it will becomes minus 1. There are three things I actually left, this one I didn't calculate these four, right? Hopefully you guys can also try something, right? Because I don't want to do everything in front of you and you will be just sitting and listening, right? You will be practicing for yourself as well, right? So try to practice that. And I got a coefficient matrix now. This is my coefficient matrix. The coefficient matrix now is equals to nothing but minus 11 minus 4 6, that is one row, minus 11 minus 4 6 for one row. Second row is 2 0 minus 1 2 0 minus 1, and your third row is 2 1 1 minus 1 2 1 minus 1. If you will be looking closely, this is a 3 cross 3 matrix. What we taken initially we have taken a 3 cross 3 matrix. So we got a coefficient matrix which is also a 3 cross 3 matrix. Now we will try to figure it out when you have adjacent of it. Okay, so what we will try to do, we will try to say transpose, we will try to say transpose to get the adjugate. Adjugate matrix, that is the adjoint matrix, what I am trying to say actually. The adjoint matrix can come, is the adjoint A is nothing but the coefficient matrix inverse, transpose, coefficient matrix transpose. And we know what is the transpose means. Your column becomes row becomes columns, that's why it becomes minus 1 minus 4 6 2 0 minus 1 2 1 1. Okay, this is your adjacent matrix. And I already told you what is the inverse of a matrix. The inverse of a matrix is nothing but 1 by adjacent of a or adjugate of a into determinant of a. Sorry. Again, I'm making mistake. 1 by determinant of a into adjoint of a. Right. Now I have a adjoint matrix. The adjoint matrix is minus 11 2 2 minus 4 6 0 1 minus 1 1 divided by my adjoint of a matrix is what? Adjugate of a matrix value is, my adjugate of a matrix value is, or determinant of a value is this 1. My determinant of a matrix is 1. It's a very big concept, right? 1. So if you will be doing by divided by 1 in all the values, right, all the value positions, so it will be, you will be getting the same values, right? So the minus 11 minus 4 6 2 0 minus 1 2 1 1. This is my inverse matrix. It is my inverse matrix. Do you guys understanding what I am trying to do here? I did lot of things, right? I did lot of things in this adjoint matrix. Hopefully you guys are cleared about it. This was actually a little bit a big session. We'll try to figure it out in the next session about more about matrix operations, and again we'll go deeper and deeper into matrix. So hopefully you guys enjoyed the session. We'll be meeting in the next video. Bye bye. See you. Jai Jagannath.